Today we're going to be talking about linear equations. So first of all, let's talk about what a linear equation is. First of all, we know that because it says that it's an equation, it has to have an equal sign in it. Okay, an expression does not, that's what we dealt with last time, but an equation has to have an equal sign. So that's going to be your first clue, is we have to have an equal sign. So algebraic expressions and linear equations look very similar, and so it can be anything from x plus 8 equals 10 to something much more complicated that has parentheses and exponents, like 2 times x squared minus 4 is equal to 10x plus 5. Both of these are going to be examples of linear equations. Okay, notice that they both have an equal sign in them, and then they also have a variable in them that we're going to solve for. All right. The reason that these will have a variable, and they might have two, that's fine also, but the reason that they're going to have a variable is because both of these, if we graph them, will create a line, and so that's where our key word or our root word here, line, comes into play. So a linear equation is an equation where if you graph it, it will make a line. Okay, and that can be a horizontal line, it could be a vertical line, or it could be a line with some other slope, right? Just depending on what all is included in that equation. Okay. In order to solve these, we are going to need to be able to identify our opposite operations. So for example, if I had x, excuse me, that seems to be having some difficulty. If I had x plus 8 equals 10, and I needed to solve this, I have to be able to move this plus 8 from this side of the equal sign to this side. And in order to do that, I have to be able to identify my opposite operation. So I have a plus sign here, and so I'm doing the opposite of adding. So the opposite of adding is subtracting, right? So I'm subtracting 8 from both sides of the equal sign. Okay, over here, 8 minus 8 is going to subtract out to be 0. So I have x plus 0, you don't need to write, is equal to 10 minus 8, which is 2. So my answer then would be x equals 2. And again, in order to solve that, I have to be able to identify my opposite operation. So the opposite of subtracting, right, is going to be adding. Right? So, and then we have our other two operations over here. The opposite of multiplying is dividing, and the opposite of dividing is multiplying. So you're going to notice that these are like a little two-way streets. So it's not hard to remember. I think most of you probably know this already. An example for the second one, if I had 2x equals 10, notice I've multiplied here, so I have to divide by 2. So there's an understood multiplication sign here. So I'm doing the opposite. I'm dividing by 2. 2 divided by 2 is 1, so I have 1x left here. And 10 divided by 2 is 5. So x equals 5. Okay, so let's look at some more examples. Here I have x plus 8 equals negative 5. So I'm always looking to get the variable, in this case x, by itself. So I'm moving everything else away from the variable. I do still have to follow my order of operations. That was the PEMDAS that we talked about in the last section, 0-4. So if you don't remember what those stand for, either look back in your notes or go back and watch the 0-4 about algebraic expressions. Okay, so we're trying to get our x by itself. So we have this plus 8 that's been added over here. So we want to do the opposite of that. So the opposite of adding is subtracting. So I'm subtracting 8 from both sides. 8 minus 8 is 0, so those cancel out. And I have a negative 5 minus a negative 8. So I have the same sign, so I have to add the numbers. So I know that 5 plus 8 is going to be 13. And then because they have the same sign, I keep the sign. So those are both going to be a negative, right? So I keep that sign, so it's a negative. So on this one, the answer is x equals negative 13. Okay, let's try another one. Okay, On here, my variable is p, so I'm trying to get p by itself. And again, I have a plus 27, so I'm doing the opposite. I'm subtracting 27 from both sides. Okay? So the plus 27 and minus 27, those cancel. So I just have p over here. This time, I have different signs. So this 12 doesn't have a sign in front of it, so it's an understood positive. And so that's going to show you I have a positive and a negative for the sign. So my rule is if I have different signs, I subtract the numbers. So I'm going to do 27 minus 12, which is going to give me 15. And then I take the sign of whichever number would be the bigger number. So 27 is a bigger number, so this is going to be a negative number. And if you're confused about where I'm getting these rules from, you want to go back and watch my video either on YouTube or on our Schoology account about adding and subtracting with negative numbers. Okay, there's a fun little song. So let's look at another example. Okay, this one is dealing with multiplying. So I have 5 times g. Remember that this 5g is the same whether it's written the way it is in the problem or if it's written like this, or it could be written as 5 times g. All three of those are exactly the same thing. And we have it written as 5g equals 35. So I want g by itself. So the opposite of multiplying is dividing. So I'm going to divide both sides by 5. And my 5 divided by 5 turns into a 1. So I have 1g. I'll give it a little tail there. So that's 1 times g is equal to 35 divided by 5. So if you divide that out, you should get 7. Remember this 1, we don't really have to have it, so you can also write it as g equals 7. Okay? All right, another example. This time, we have a division problem. I have 4 divided by 7, and that's times x. And it doesn't matter, again, if they have it written as 4 over 7, or if they had it written as 4/7 times x. Let's see, if they had drawn it where the line was under both the 4x, the 4 and the x, and put all of that over 7, all three of these are exactly the same, okay? And so in order to do this, remember we're dividing here, and I want this x by itself. So I have to get rid of the 7 down here in the denominator. In order to do that, I have to do an opposite operation. So since this is saying divided by 7, I have to do the opposite. I'm multiplying times 7 on both sides of the equal sign. And this is just the same as what we did before. You have to do what you do to one side, you have to do to the other. So if I multiply by 7 on the left, I have to multiply by 7 on the right also. Okay? Over here, 7 divided by 7 is going to cancel out. It's just 1. 1 times 4 is still just 4. So I have 4x. And then I'm doing negative 3 times 7. And that is going to be negative 21. Remember, the rules for multiplying with negative numbers are if you have 1 negative times 1 positive, the answer is always negative. If both of them have the same sign, it's always positive. Okay? So from here, it looks just like what we were doing before. I have 4 times x. That's the same as 4 if you have a multiplication sign there. So I'm dividing, so that's the opposite sign of what's being used. So I'm dividing by 4. And if you were to type into your calculator 21 divided by 4, you would get a decimal. Okay, and so it's really a matter of how do they want your answer written for that question. So be sure you read the directions. If it asks you to just leave it, or if it doesn't say anything else, if it just asks you to evaluate it, then you would leave your answer as a fraction. And so negative 21/4 would be your answer. If it asks you to round, okay, then you would write it out as a decimal, and this one would be negative 5.25. Okay. Oh, sounds like they're practicing with the music here at school. Just a moment. Okay, they finished their practicing with the music. So in our book, be sure you're reading your directions. Oh. Okay, let's try this again. I think they finally finished with the music. So in our book, be sure you're reading the directions, because sometimes they're going to want this first answer, and if they don't tell you anything, you want to go with this first answer. But if they tell you to round, you would go with the second answer, that's a decimal. Okay, so just keep that in mind. So let's look at another example. Okay, so our last example here, we have parentheses. So remember that on PEMDAS, our abbreviation for the order of operations, that means that we have to get rid of those parentheses. We have to get rid of the parentheses first. And in order to do that, we have to distribute. So we have to take this 3 and we have to multiply it times the x, and we have to multiply it times the -5. Don't forget that this little negative sign here, it goes with that 5. Okay, so 3 times x is 3x. 3 times -5 is -15. And then we just bring everything else straight down. Okay, from here, we're solving it just like we did any of the other ones. So we want the x by itself, so we're moving everything over to the other side. So I have this -15. I have to do the opposite. Since it's -15, I'm adding 15. Okay, and -15 plus 15 is 0, so it cancels out. And then I have 3x equals 28. Okay, next, I still have this 3 that's attached to my x, and I want to get rid of it. It is multiplied. Remember, there's like an understood multiplication sign in there. So the opposite of multiplying is dividing. So I am dividing by 3 on both sides. 3 divided by 3 is 1, so those cancel out. And 28 divided by 3, if I type that in my calculator, I'm going to get a decimal. And so, again, depending on what your question is or your book is asking you to do, your answer would be 28 divided by 3, unless it asks you to round, in which case your answer would be 9.33 repeating. Okay, so again, for the most part, our book is looking for this 28/3. All right. I hope that this has been helpful. If you have any questions, come and see me during 0 hour. Otherwise, I hope you have a lovely afternoon. Thank you.